all boxes of the flowcharts are connected with arrows. Right? All boxes of flowcharts are connected with arrows. So we know, we know, right? Everything. All boxes of flowcharts are when you have a when you draw a flowchart, right? So we have different symbols, right? So we have to connect everything using arrows. So that's the first point. Second one, flowchart symbols have an entry point on the top of the symbol with no other entry point. So if you take a flowchart symbol, so there's an entry point, right? So if you take, let's say, calculation, so there's an entry point, right, on top of the symbol. So you can't have another entry point somewhere again, right? So that's the point. So flowchart symbols have an entry point on top of the symbol with no other entry points. So note down these general rules for flowcharts. If you don't understand anything, please tell me, right? If you're not clear on any points, please let me know. So second point, flowchart symbols have an entry point on top of the symbol with no other entry points. So I hope that is clear, right? Flowchart symbols have an entry point on top of the symbol with no other entry points. So you can't have two entry points to the flowcharts, right? If you take any symbol, right? Any symbol, you can't have two entry points. So usually you have an entry point at the top here, at the top. The third point, the exit point for all flowchart symbols is on the bottom except for the decision symbol. So exit point for all the flowchart symbols, right? Except the decision table is this, right? For all others, right? All others, exit point for all flowchart symbols, exit point for all flowchart symbol is on the bottom except for the decision table. So if you take a flowchart symbol like the calculation, so there is exit point in the bottom, right? But the exception is the diamond, the decision table. Decision symbol is what? The diamond one. So fourth point, the decision symbol has two exit points. So if you just join, you can, we are actually writing down this. Maybe you can take a screenshot and you can copy down later. Basically, we are making a note on this. So this is what we have learned so for the flowchart. So we'll continue the past paper question in the next class, that is on Saturday class. So today I'll be hoping to start the pseudocodes, right? The fourth point, the decision symbol has two exit points. These can be on the sides or on the bottom and one side. You know this, right? If you take a decision symbol, this has two exit points, maybe one from here, then there's another one, right? Sorry, two exit point, one here, right? And another one is like yes and no. These are the exit point. This is the entry point. This is the entry. So you have two exit points. So going out from that symbol. And finally, generally a flow chart will flow from top to bottom. Top to bottom means you start from the top like this, right? So then it follows to the bottom like this. So you don't write the flow chart from bottom to top. So you don't do that way. See, these are the general, rules for flow chart, right? If you don't understand anything, these are very straightforward. But if you don't understand anything, please tell me. You can message me or maybe you can talk. Just let me know. I will explain it if you don't understand anything. Yes. Can you explain second one? Second one, flowchart symbols have an entry point on top of the symbol with no other entry points. Okay. Okay, Raisa, let's see. Give me a minute. Here, okay, let's take a simple flowchart, right? Let's take a simple one. Start. Flowchart. Now, if you come to this one, let's say you have a calculation here, right? Now, look at this one. This has a entry point. So this is what you call the entry point, right? This is what you call the entry point, right? So the flowchart symbol have an entry point on the top of the symbol with no other entry point. So you can't have another entry point, no. Right? So that's the idea. Right. Okay. Right. Now we know. Remember what is an algorithm? What is an algorithm? So we basically represent Tamima Faiz, who's this? In the end symbol, you can have more than one entry point, right? In end symbol, yeah, you're true. Yeah, you're correct. Tamima Faiz, who is that? Uh, the end symbol, yes, very good. So if you look at the end one, right? Yes, if you look at the end one, yeah, you can have different entry point. Yes, these are not rules, right? What I have given is just some basic idea about the flowchart. So don't take it as a Hani. Okay, right. Okay, so don't, these are not rules, just general idea about about flowcharts. Okay, so we know, right? Okay, when it comes to the pseudocode, right? We said, we can design an algorithm to solve a problem. After that, now we have to represent the algorithm. So one method that we learn to represent algorithm is what? How do you represent algorithm in computer? I mean, we said there are two methods you can use, right? One is what? Yes. What is the method?
Flowchart.
Flowchart. Yeah, flowchart. Simple one, right? Flowcharts. So basically, flowchart is like we use symbols, right? We use symbols. There's another method which is widely used called pseudocode. So we write it like this, pseudocodes. So pseudocode is basically a text base. We don't write symbols here. These are text. So the same idea. So yeah, Atika, you're correct. First one is the graphical. This is graphical representation, right? Graphical representation. Then this is the text representation. So pseudocode is basically a simpler version of programming code. So you don't write, before you write the programming code, right? We write the instruction in a simple English kind of, language. It's not a language. It's not a programming language. We write it like a simple English letters, right? Before you convert to any programming language, right? So pseudocode is a simpler version of a programming code in plain English before it is implemented in a specific programming language. Okay, so but this has no syntax. Like if you take a programming language, later we will see. Okay, when you learn programming languages like Pascal or Python, Java, there is a specific way of writing, right? So there are syntax. We say there's a syntax, but pseudocode doesn't have any syntax, right? You don't have any syntax. We'll see what is that. So that you can't compile it, you can't run these codes in programming in computers, right? Because these are not, a computer. Pseudocode is not a computer programming language code. So you should understand that it's a representation of algorithm, right? Don't worry. So we will be doing that. So it's work as a rough documentation. So the program of one developer can be understood easily when a pseudocode is written out. Okay, because it's independent from the programming languages. So you write pseudocode independent from the programming languages. So so this is basically the introduction, right? So okay, you can note down this pseudocodes. Don't worry, because we'll see examples, then you will understand really what this means. Okay, pseudocode. Pseudocode is a simpler version of a programming code in plain English before it is implemented in a specific programming language. For example, if you want to write code in Python or Pascal, you have to write the pseudocode before that. Then maybe you can convert it to any language. So that's the advantage of having the pseudocode. Note down the first point. Pseudocode is a simpler version of a programming code in plain English before it is implemented in a specific programming language. Second point. So it has no syntax like any of the programming languages, right? Thus can't be compiled or interpreted by the computer. So you can't run this as a programming language. Okay, this is independent from programming language. So note down, it has no syntax like any of the programming language, and thus can't be compiled or interpreted by the computer. We'll see what is compiling and interpretation later. So maybe you can note down, you can leave the third point, right? So write down the fourth one. It is a methodology, right? This is the first one, second one. Okay, maybe if you want, you can write down. Okay, we'll write down that also. This work has a rough documentation, so the program of one developer can be understood easily when a pseudocode is written out. Then the fourth one, it is a methodology that allows the programmer to represent the implementation of algorithm as we discussed. So there are we have two methods to represent algorithms. One is graphical way, that is the flowchart. Then the second one is the pseudocode. So it is a methodology that allows the programmer to represent the implementation of algorithms. So note down that also. Okay, now, so don't, I mean, just note down this, right? So we'll use it later. So these are the basic, what do you call, items. So terms we are going to use. Okay, you know, we know this, what do you call, flow chart. So when you take a flow chart, basically you have an end, begin. So begin, you have a begin. So we write usually in block capitals, begin, right, to start the pseudocode. And to end the pseudocode, we use the end. So you can note down this as well. Let's use simple English terms. Let's us see. Okay. These are the terms used in pseudocode. So note down this. Don't worry. So because we're going to use it later. So begin to indicate the beginning, end to indicate the end, then input or read or get anything, any of this, right? To indicate an input. So when you have an input, we know in flowchart we write this parallelogram, but here you can use any of this input, read or get. You can note down this also. Then to show the output, you write the output, the word output or the display or show any of this. And if there is a process, you can write the process or calculate, but sometimes we don't write it, we can omit that also. We see that is, what is that? And when there's a decision or when there's a if-else condition, we write if, then else, and there's an end if. So I will explain that, right? Or you can write, we write it like this, selections, right? Selection. So when there is a loop, we use for do, right? Just note down this. So can you show the last slide once again? Last slide. Oh, wait. Yeah. Okay. Is this the one, Zahra? Okay. Okay. Zahra, can I move? Okay. Now note down this point. Okay, is anyone writing this still? Raise the hands if you are writing, please. Okay, okay. Okay, fine. Continue. Okay, no issues. Actually, this part should come here. Used to indicate selection. So that should come here, right? So when you copy down, write down this bit. Write down this one, I think, here. And this is what you call, you can say, repetitions. So don't worry, I know you don't understand anything. So, but we need, this kind of introduction. Then, we'll proceed with the examples. Yeah, anyone still writing? Atika, no, Hafsa, Uzma. If you have finished writing, you can put the hands down. Okay. So let's start with an example. Then we'll come to that. There are some, best practices. So we'll come to that later. Right. So again, remember when we learn flowcharts, we learned we categorize into three, right? We started with the sequence ones. Remember, then the selection, then the repetitions. Right, like that, we're going to do the same thing here, right? Okay, you can write down the heading, the sequence structure. So you can write down the heading sequence structure. Okay, draw a flowchart for program to input two numbers and display the results of addition. So don't draw the flowchart here. I will show you. I will give you the flowchart. Draw a flowchart for a program to input two numbers. Again, okay. So bit of writing today. This is the heading sequence structure. Right, write down this, draw a flowchart. We already did this question, okay? So don't draw the flowchart. Draw a flowchart for a program to input two numbers and display the results of addition. Now, convert the above flowchart to pseudocode. This is what we are going to do. So write down this complete question. Draw a flowchart for a program to input two numbers and display the results of addition. Basically, you have to input two numbers and add, and then you have to show the addition or the total. Convert the above flowchart to pseudocodes. So maybe you can refer to your old notes, right, to get the flowchart. Again, remember, we are going to categorize this into three types, like a sequence structures and the selection, then the repetition. So we'll do as we did the flow charts. Okay, we'll do first the sequence one. So we know what is a sequence one. Okay, who can explain what is a sequence structure? Yes, what is a sequence structure? Najat, what is a sequence structure? Sequence structure goes in a step-by-step structure. Very good. So it goes in a step-by structure. There you won't see any conditions. So you don't see any repetitions. You don't find any repetitions. Just a sequence ones, right? That is the sequence structure. Okay. So instructions are executed one after another. Yeah, instructions are executed. The main difference are in you don't find conditions like, okay, if this is if conditions, so you don't see any if conditions or any repetitions like loops, right? So you don't repeat, so there's no repetitions, so no conditions, no repetition, just the sequence ones, right? Okay, now this is the flow chart now, right? Okay, now this is the flow chart. Maybe you can draw it. If you don't have the flow chart, you can quickly draw the flow chart. Now let's see how to write the what do you call pseudocode for this type of program, right? Right. So how do we write it? Start. So we have to start the program. So we write it with the capitals, but you don't. This is not a strict. Okay, we'll write it like this. Okay, start with the begin. Right. Remember the keyword. I said you start with the begin here. Right now, let's follow the flow chart. Let's follow the flow chart. After the begin, you have what? You have the total equal 0. So we assign, right? We assign it. So then we write that one, right? Sorry. Second one, we say total equals 0, right? Okay, now input. Now see, you have an input statement, then you can write it like input, or you can use read, right? You can use input, either input or read, as I said. But let's maybe let's use the input, right? But when you look at the past papers or other books, you find input, read, and get as well, right? So you can use any of this. Okay, now we have to get the, okay, what is this part? What is this? What is this? So you are adding these two numbers to get the total. So we say this is a calculation. This is the calculation part, right? This is the calculation. So there's a calculation, right? The process, yes, there's a process, yeah. So how do you write the process of the calculation? The calculate, you use the keyword calculate, right? And you write the total N1 plus N2, but later, you know, we will see, we won't use this much, right? So you can omit this, right? So let's write it now, right? Calculate it. Now output, the next one, next step, I'm following the flow chart, right? Go with the flow chart. Show, or you can say display. Remember, you could go back to the note and see. So how to display, use the word show. Then how to end this program? End. So this is the simple flow chart. Is it the must to write in capital? No, it's not must. I will come to that. These are best practices, Asmat. These are best practices, but you will see it later. We won't be bothering writing this in capitals. So, but as a first example, just copy down this, right? And you should notice one other thing when you write this, right? Clear. Okay, attention, please. So when you write it, see this one. We started the flow pseudocode. This is our first pseudocode. And we end the pseudocode here, and you can see the indentation here. So we indent to the, you know, everything to keep inside the begin and end. See that this is also best practice. These are not rules. Even if you don't keep this indentation, even if you don't keep this space, this is correct. Even if you don't keep the space, that's not wrong. But these are best practices, right? Because you know why? Like programming languages like Python, you know, you must keep the intent. That's a rule in Python or syntax. So that would be handy if you learn. Or let's say if someone, or if when you read this code, you know everything. Okay, you know, okay, all these codes comes under this pro box. Okay, that's even clear idea. So better you indent this, right? Indent the, if you start the begin, then keep some space and follow the same space. See, there, if you look at this one, I have followed the same space from the, what do you call this is left side, right? Left margin. So, but look at the begin and end. So you keep the begin and end and you just indent and write everything inside that. That's a best practice. Again, this is a best practice using the capital best practice, right? Okay, I will give that later. Okay, so this is the first program, right? So you can copy down this. Isn't it calculate total 0? No, calculate total equal 0 is not a calculation. This we say this is an initialization, right? So you are initializing the value. So not a calculation. Don't worry about this calculation, Adila, Fadila. So we probably we won't be using this. Okay, note down this. If you don't understand anything, a very simple one. So I didn't because I don't want to explain the logic or the algorithm here. It's a clear one. If you have any questions, just ask me. Now you note down this pseudocode along with the flowchart. So it's better if you have both, right? Maybe maybe you can take a screenshot of the flowchart and later you can copy down the flowchart. Now you should write the pseudocode. Okay. Any questions? Any questions? Right. Second one, draw a flowchart for a program to input two numbers and find the large number. This one also we already did. We already covered this one. Okay. So write down this question. Draw a flowchart for a program to input two numbers and find the large number. Then convert the above flowchart to pseudocode. So we have these flowcharts. Okay. So we already did this one. So write down this question, second one. If you don't understand anything, please let me know. Draw a flowchart for a program to input two numbers and find the large number. Convert the above flowchart to pseudocodes. So our main idea is converting the flowchart to pseudocode. So now what we are doing is basically we convert all the flowchart what we did, not everything, most of the flowchart to pseudocode. Draw a flowchart for a program to input two numbers and find the large number. Remember this. What is the algorithm? How do you do this? So you input two numbers and find the large number. Remember, right? Convert the above flowchart. Write down this question. Okay, right. So this is the flowchart. So flowchart, I have given the flowchart. Now, so okay. So we don't, sorry. Give me a minute. Right. Now, okay, now because this is not a sequence structure, but let's see how to write this one as an example, right? Okay. Here, look at this one. Look at this one. So you start it like begin, right? So begin the flowchart. Then now I'm using read, or you can use input, whatever. So read in1 and in2. Okay. Now I will explain this later also, right? Now we have a condition. See, we have a condition. If n1 greater than n2, then write the keyword then. If this, right, then. And what you have to do, if this condition is true, we have to display the n1. So you display the n1, right? Else, so you have to include an else, right? Else, that means the no part, you have to display n2. So this is the no part. And what you have to do with an if statement, you have to include this special word end if. So that's all. That's the problem, right? So this is how you write a condition in pseudocode, right? So we'll do more exercises. Don't worry. This is just an introduction. Okay, so note down this. Maybe if you want, you can draw the flowchart later. So keep some space and take a screenshot of this flowchart and draw it later. But now write down the pseudocode, right? So we write the pseudocode. So you start the program begin, and input you can use read. See, read. Sir, can you show the question, please? Oh my God. Okay, wait. Question is, Sarah. draw a flowchart for a program to input two numbers and find a large number. Basically, we have to convert this flowchart to pseudocode. This is an example for selection one, right? Is the capital letters are important? No, Hamdi, it's not important. But we'll start with the capital. Later, I will tell you. You can forget about the capital, right? So now we'll just start with the capital because this is the first example. No? So you write the capital now. Later you can forget about this. Done. Okay. Is anyone still writing this question? Raise the hands. Okay. So this is the flow chart. So I don't know because we already did this. Now we'll note down this. Okay. So how do we write it? So begin and the space, the indentation is important. Look at this indentation. So when you write the if statement, again you keep some space inside. So we know that display statements comes inside the if. See, look at this. So we have a line here. So everything comes this line, but these two are like it's inside the if statement. So we know this statement comes inside the condition. Inside, that means if the condition is true, you display. If the condition is false, you display N2. If the condition is true, you display N1. Basically, that comes inside the condition. So that's why you keep some space, some more space, right? Okay, note down that also, right? So when there's a condition, so we take the if statement to compare it and the then, if then. And you display, maybe you can say output display, right? So I have given the keywords, you can use those, whatever. Then if else mean, else mean this is your no part. No, that means if the condition is not true, what you have to, right? If then mean this is the true, if the yes part, if the condition is yes, you do this one. If the condition is yes, you display the N1. That is this. Right? If the condition is false, right, you display N2, that is here, then you have to include the keyword, what? Else. See, else keyword. Finally, you have to insert a keyword, right? That is called end if. You have to insert this keyword end if. Okay, this we use end if to identify the end of this statement. Okay, when you see an end if, so we know this is the end of this statement. So that is the end if. So finally, you have the end. Okay, note down this one also. If you have any questions, raise, you can ask me. But these are, like a theory class, so just write down. So we'll see the application. So we'll do exercises. Okay, sorry, I had a connection problem. So hope you can hear me, right? So I had a sudden connection problem. So I'm back now. Let's start. Okay. Right. Okay. Okay. Right. Now let's do this one. Draw this flow chart. Draw this flow chart and write the pseudocode for this. Okay. Draw the flow chart. You have to draw the flow chart. Quickly draw it. Or or shall we do like this? Maybe you can draw the flowchart later. Keep the space for the flowchart, right? By looking at the flowchart on the screen, write down the pseudocode. So that way we can save the time. So you can take a screenshot or whatever. Draw it later. So you can draw the flowchart later, right? Draw it later. Draw later. Now you have to convert this flow chart to pseudocode. So write down the pseudocode. Uh, After that, you can complete the note. Is that clear? So you can take a screenshot of this flow chart and complete it, right? Now just write down the pseudocode. You can write it now, right? So start. Very simple one, very easy one. So we'll take like 2 minutes maximum. Yes, if you have completed, raise the hands. Whoever completed, please raise the hands. If you have completed, raise the hands, please. Right. It's okay. How do we write it? First, so okay, we'll start the flow chart. Start the pseudocode, sorry. So begin, right? Right. What is the next statement? What is the next statement? Input two variables, L and W. So you can use input or you can use the keyword input, right? We say L, comma, W. Or if you want, you can use read or get. Right. Now there's a process. As I said, you can use the process keyword, A equal L into W. But, usually we don't use this. So I'm going to remove that. So that is not important, right? Right. Then the last statement, you have to display it. So you can say the display, or you can use other keywords as well. Display A. So next, you have to stop it, you end. So this is the answer. So this is the flow chart. See, very simple one, very straightforward one. Right? Let me keep this one. So then it's easy. Yes, any questions? So don't we have to initialize A equal to, no, don't worry about that part because you just need to, we are just converting the flow chart. So initializations, you don't need actually, sometimes you need, but that's you don't worry Rida for the time being, right? Since they have not given that in the flow chart, you can't include an extra word, like you can't say A equal 0. right? So, because basically what we are doing is we are writing the pseudocode for the given flowchart. Or in other words, we are converting the flowchart. We are converting the flowchart to pseudocode, right? We are converting the flowchart to pseudocode, right? So, any questions on this? Easy, no? Okay, second one. Again, second, we did this exercise. So you can, as I said, you can leave some space for the flow chart, then take a screenshot and you can write the flow chart later. Now write the pseudocode. So I want you to write the pseudocode. Okay, take 1 or 2 minutes and complete it. So I wrote, yeah, if you write the calculate, that's fine. Yes, Shihan. Yes, you can write down, right? If you include calculate, that's fine. But normally, what we don't, right? Even if you go to the past paper, you will see you don't find the calculate word. Right. How many of you completed this? 8, 9, 10, 11, 12. Yes. Very simple. No, everyone can do. Uzma, Nirukshi, Kirtika, I hope Umar. Right. So look at the answer. So very simple. So start like begin. So there's no start keyword here. So be careful with that. We don't use start here. So begin the program, begin the pseudocode. Then you can say input or read, right? Get. Then the process part, the process, then display it. That's all. Any question? The third example. Yes, someone switch on the mic. Okay, third one. Okay, can you do the pseudocode for this one? Write down the pseudocode for the third one. Oh, basically you have to convert the flowchart to pseudocode. It's okay. I think you include a bracket here, right? Otherwise, it's wrong. Yes, if you have done, raise the hands. If you have completed, raise the hands. Right, okay. So I will share the answer. If you have any doubt, you can ask me. Right, correct your answers. So again, the same thing. You can correct your ones, very simple one. Right, and keep the indentation, see? So you write the start, begin, then keep some space, include all the other statement inside that, and you can end it, right? Right. So next one. What's this? 1 minute. Okay, let me share the screen. Okay, next question. Next one. Right. Last one for the day. Can you write the pseudocode for this one? So these are very simple one. So can you quickly write the pseudocode for this? Yes, once you're done, raise the hands, please. Yes. How many of you completed? Please raise the hands if you are completed. Okay, can someone read your answer? Who is willing to volunteer? Yes. Shall I read a name, or is anyone willing to read your answer? Zohra, can you read the answer?
Begin.
Better. Begin, okay.
Input bill.
Input, okay.
Discount equals bill into 20 over 100.
Okay, bill into 20. Okay, let's write it like this, okay.
Payment equals bill minus discount.
Minus discount, okay. Anything, sorry?
Payment.
Display payment, right? That's all right. So we are done. Yes. So very simple, right? Very simple. Nothing, right? Actually, nothing here. So let me keep this on. So you can check your answers. If you have any question, please ask me. So we don't use this process here, right? Right. Now the last one. We'll end with this one. Right. Now, can you write the flowchart pseudocode for this one? Write the flow pseudocode. Yes, who have completed, raise the hands, please. Okay. So let's begin, right? That's easy, right? After that, we have the input marks, or we say read the marks this time. Read the marks, right? Okay. Okay, next step. Now, how many of you completed? 12. Okay, how about others? Fadila, Samiha, Shihan, Uzma. Okay, now let's see next step, right? Now we have a condition. Look at this one. We have the if the marks, right? So how do you write the pseudocode for that one? If marks, right? So we are converting this one, right? So now there's a condition. We say if marks greater or equal to 50, and then what you have to do? Yes. Then what you have to do? Yes. If the marks is, if the condition is true, what you have to do?
Display pass.
Display the pass. Okay, we'll write like this. Else, include the keyword else, right? Else, leave some space. Else, what you have to do? Else means the condition is false. Else, what you have to do? You have to display the keyword, the term, the fail. Now you have to end this end if. That is this is how you indicate the end of this if. Right? So we are done. Now you can end the pseudocode. So this is how you write. Right? So if you go one by one, so look at this one. So later, this is, we converting the flowchart to the pseudocode, but without writing the flowchart, you should know how to write the pseudocode also, right? So we'll come to that later. Okay, you can correct your answers. You can correct your answers. Let me keep it this one.